Hello and welcome to Basic CRT Repair. I am Ian Primus. I have done this talk a couple of times at VCF East over the years. It's usually an hour long, and I also usually have an audience to interact with while I'm doing it. So this is going to be a little bit new for me. Shooting and editing and producing video is not really my forte, so forgive this if this comes out kind of messy. But I'm going to do the best I can to cover the information I like to usually cover in these talks, get it down to an hour, to half an hour long, and be able to show things clearly on camera. Of course, the one thing that comes up the most when talking about CRTs is safety. The number one question I always get, or number one concern from anybody that's never worked on one, is how to discharge the CRT, how to work on one safely. There's a lot of myths, there's a lot of misconceptions, there's a lot of scary things out there talking about how, CRTs store a charge after they're unplugged, that the high voltage can kill you, that you should never work on one alone, you gotta keep one hand in your pocket. A lot of that's pretty excessive. While it's true that they do contain high voltage, I mean, this is a set I'm going to be using for several demos. This is a boring, ordinary 13-inch color TV. I'm using a TV set because the casing design makes it really easy to show inside clearly what's happening. It's also very simple. This is a cheap TV, so it's cost reduced to within an inch of its life. It uses as few components as necessary, so it makes it pretty easy to see what's happening. Computer monitors, the monitors in terminals, all those things operate on exactly the same principles. But the first thing I want to cover is safety, how to discharge a CRT so you can disconnect the anode and work on it, because I'm sure this is the one thing that everybody wants to see the most. The component that stores the high voltage is the CRT itself. It actually works as a capacitor in the high voltage circuit. It is coated on the inside and the outside with conductive paint. The flyback transformer generates the high voltage, but it's a high frequency AC. There's a diode built into the flyback transformer's casing that turns it into DC, and then it is filtered by the fact that the CRT functions as a capacitor. One plate is on the inner coating inside the glass that this anode connects to. The other plate is this outer gray painted-on coating called the aquadag, and then the glass of the tube works as the insulator, and that forms a capacitor. The problem is that whenever you unplug it, turn it off, that capacitor stores a charge. Some sets bleed it off, most sets don't. And even if the set does bleed it off and you know this, I wouldn't trust it. Always discharge it before you disconnect it. Discharging is something that scares a lot of people, but it doesn't require any special tools and it's completely safe. All you need is a flathead screwdriver. This is just an ordinary plastic handle flathead screwdriver, and a clip lead. This is just a cheap, probably Harbor Freight clip lead. It's nothing special. So what you're doing, though, is you're not grounding it, you're not doing anything weird. All you're doing is you're shorting out the capacitor formed by the picture tube. What you want to do is you're connecting the internal plate to the external plate, shorting out the capacitor and discharging it. So what you do is first you have to make sure it's unplugged. Don't try to discharge a CRT that's still on. And you can see that you can see this inner coating here, kind of through the glass. You can see the gray outer coating. You see this strap. This is the DAG ground strap, and this connects along the back of the tube, pressing against that gray coating, and it goes to one of the metal mounting ears here. And these ears are all connected to each other by way of the implosion band that goes around the front of the tube. So all you have to do is connect one end of the clip lead to the shaft of the screwdriver, connect the other end of the clip lead to this metal, that DAG ground strap, or to one of the metal mounting ears of the tube, and then slide the blade of the screwdriver under the suction cup until you touch the contact inside. Hopefully the camera picked up that snap noise. That was it discharging. Now there's no voltage here. Now I can take this apart safely without hurting myself. The contact here looks about like the top of a Christmas ornament, where it's got two little prongs, and that clips into this hole. It's like a metal button with a hole that's recessed into the tube, and this clips into that. I like to use the screwdriver to unhook one side of it and then lever it out. Now that it's discharged, we can work on it safely. One thing to be mindful of is that some larger tubes, like 25-inch, 27-inch, and other big stuff, and even small tubes to some degree, this can sort of start to recharge in the same way that certain large capacitors do. It's not a big deal. It's not going to hurt you. Just be mindful that there might be a charge that comes back to this after it's been sitting unhooked for a while, but it'll be minimal. It'll be like getting zapped by a doorknob or something. Now that that's disconnected, this is safe to work on. Like I said, this is nothing special. You don't need a special high voltage probe. You don't need any kind of special insulated things. I've heard of people wearing rubber gloves and standing on a rubber mat. It's not that big a deal. The high voltage, even if you get zapped by it, it's not going to kill you. You're going to wish you hadn't done that. It'll hurt, but it's still a very low current. It's not enough to injure you. I've done talks like this and demonstrations and shown people how to discharge CRTs for a long time, and I've always told my audience that if you ever manage to kill yourself working on a CRT, send me an email, let me know how you did it. So far, never heard from anybody, so I think everybody's fine. But in all seriousness, no, it's nothing to be afraid of. It's not that big a deal. It just requires a little bit of confidence and understanding what you're doing. You're shorting out the picture tube. You're not grounding anything. You're not, I've heard of some people that try to make a discharge tool by attaching the screwdriver to the ground pin on the AC wall socket. But that doesn't work because that's not a complete circuit. It'd be like trying to discharge a car battery by connecting the 12-volt terminal to the ground. There's no current flow there. But that's really all there is to discharging a CRT. The basic components of a CRT. At the neck of the tube, we have an electron gun that fires the electrons toward the face of the screen. The second anode up here, this high voltage anode, this is responsible for generating the accelerating voltage that pulls the electrons toward the face of the tube. On the inside of the tube, it's painted with phosphors. When these are hit by the electrons, they glow. So you have this beam, it gets accelerated, hits the face of the tube. Left to its own devices, it would just create a spot right in the center of the screen, and that's not too useful. So we have this magnetic coils here on the neck of the tube. Electrons are deflected by the magnetism, and these coils bend the beam around in order to draw it across the screen, left to right, top to bottom. And in fact, if you've seen the slow-mo guys did a fantastic video on this where they filmed the face of a CRT in slow motion, so you could actually see the beam being drawn across the screen. It's pretty neat. The yoke, here's one off of another TV. You can see these are the horizontal windings are here on the inside, and the vertical windings are here on the outside. The three beams here need to be aligned with each other. That's what these rings do. These contain tiny little magnets that set the convergence and the purity to get the beams aligned with each other and get the beam aligned with the shadow mask in the face of the tube. In a color set, just behind the glass, there is a metal screen, like a metal mesh, kind of like a screen door. Most sets use a piece of metal with a bunch of round holes in it. Sony Trinitrons famously use an aperture grill of wires that looks much more like a screen door. The purpose of this is to prevent the electron beams from striking or bleeding over onto the other colored phosphors. If you've ever had a TV that had like a weird colored splotch or got magnetized, you hear of a TV needing to be degaussed. That's because that shadow mask in the face of the tube got magnetized somehow. The other thing is that the Earth's magnetic field affects the shadow mask, and it affects the electrons. So just simply moving the set around in the Earth's magnetic field will cause the beam to hit the wrong spots. So the tube needs to be degaussed frequently. So this coil wrapped around the outside edge of the tube is the degaussing coil. This fires every time the set is turned on from cold. There's a thermistor in series with it, so as the current flows through it, the thermistor slowly increases in resistance until no current flows through the coil at all. But that creates an AC magnetic field that demagnetizes, degausses the screen at power up. Down here we have the flyback transformer. This is the component that actually creates the high voltage for the second anode. It also creates the focus voltage for the focus anode and the G2 by way of this divider network here on the back. This is a resistor divider network, and this controls here lets you adjust the screen and the screen and focus voltages. Pull the chassis out here. I mean, this is just a TV, but it shares a lot of things in common with other monitors. Here's the DAC ground wire. This connects the outer coating of the picture tube back here to the neck board, which in turn is connected back to the main chassis. I already discharged this a minute ago, so I'm safe there. Speaker. This is a very cheap TV. This is kind of an interesting example of cost reduction. You see there's this hole in the chassis? Well, if the neck board fits right in there because they manufactured this as one plate, one panel, and then broke it apart later. Much cheaper that way. There's the yoke connector. If you've ever had a problem with a TV or monitor where the picture collapses into a horizontal line and then you hit it and it pops back, chances are it's a bad solder joint on the back of that yoke connector here. Bad solder joints are a very common problem with monitors in general. If you've ever had a monitor, TV, whatever, that you can hit and make it do something weird, or it fails and you can hit it and it works again, there's a bad solder joint somewhere. Key components of a TV like this transistor here is the horizontal output transistor. This drives the flyback primary. So the horizontal frequency of a monitor is key to creating the high voltage. It works very similar to the way a switching power supply works. You have the horizontal frequency, which in this case, being a TV, is 15.75 kilohertz. That horizontal signal drives this horizontal transistor, and this drives the flyback primary and the horizontal yoke coil to scan the beam horizontally across the tube. Being a TV, this also has its own local horizontal oscillator. Many monitors do, especially if they take composite video. Some monitors don't have a horizontal oscillator at all. An example of this would be the IBM 5151 display, the monochrome one. That relies on the horizontal sync signal from the computer to then go through a buffer transistor and then drive the horizontal output transistor. So if it's not connected to the computer, it produces no high voltage. The high voltage is derived from the horizontal, so any failure in the horizontal circuit will cause lack of high voltage, lack of picture entirely. The filament in the picture tube in most sets is derived from a winding on the flyback. There'll be a separate winding just for the filament, because the filament usually is 6.3 volts. Other parts of note, this component down here is the vertical output chip. Kind of hard to see. See if I can get a better picture of one later. But this is responsible for the vertical circuit. Again, you get the vertical sync gets sent to this, and this handles the it's like an amplifier, specialized amplifier for driving the vertical yoke winding. And if you ever have a TV or a monitor that has weird fold over, then you'll have one of the capacitors connected to the pins of the vertical chip will be at fault. So you have like a little fold over on the top of the screen. I've got another set. I will probably show you that later. This is the Degauss thermistor. It's actually usually a big black block, like a square plastic block in most sets. But again, this is a very cheap small TV. TV circuit boards, monitor circuit boards in general, are very simple construction. This is phenolic. This is single-sided. This is made as cheap as possible. The nice part about that is it makes it really easy to solder to. You don't need any special equipment to desolder parts off of a board like this. The holes aren't plated through because there's nothing on the other side. Common failures in monitors in general tend to be electrolytic capacitors. but it's not like the be-all, end-all. You can't just rely on capacitors being the one true failure with everything. This particular TV is hot chassis. You'll hear people talk about a hot chassis set or a cold versus a cold chassis set. This is hot chassis. It derives its B plus from rectifying the AC line and filtering it, and then there's a voltage regulator in there. But there's no galvanic isolation. This is directly connected to one side of the AC line. This is why this set has no inputs. It has an antenna input, but that's coupled to the tuner with a capacitor in here, and it's not actually electrically hard coupled to it. So that means that if you were to try to modify this, like I know hear a lot of people these days RGB modding a TV, don't even attempt to modify a hot chassis TV like this, because it's not safe. Because you're at mains potential, the difference between your RGB input and the RGB, the ground of this TV, and the ground of your computer or game console could be 120 volts AC, which will lead to a lot of smoke and burning. But I mean, this is like I said, this is a very simple TV, very simple overview. I'm going to try to get into the more details in other segments. Yeah. Okay, so this is an example of a common sort of a failure that you see on a lot of different kinds of monitors. This is a Panasonic professional monitor. This is a 9-inch. Even conveniently on the side, somebody has written broken. And this has a vertical fault. So if I turn this on, warm up. And turn on my pattern generator here. So it's kind of hard. Hopefully it shows up on camera, but you can see that the top of the picture, like, it's squished a little bit, and then the top of the picture is getting like folded over and stretched out. So you see all these extra kind of lines that show up in the picture, how it kind of messed up like that. Let's see if I can, the color bars show it too. You can see these lines. I think it's showing up on the camera, but it is folding over. It's just that the folded over section is getting all stretched out. And this is a little bit more obvious. This is a crosshatch pattern, and this line, this flickery line, is supposed to be up here, but like that top, I don't know, a quarter inch of the screen is now folded over and stretched across half of it. So I mean, this is broken. This is something wrong with this, and this is a problem with the vertical deflection circuit. This is one or more of the capacitors in that circuit has failed. So I'm going to open this up, and I'm going to try to get some close-ups and explain the problem and how to find it. Okay, so I got the chassis out of that little monitor. And there's a lot more to taking apart a professional monitor than there is a TV set, but that's okay. Just a whole lot more screws to deal with later. So here's the main chassis. Now, again, it looks more complicated than the TV, and it is. There's a lot more going on. But it still works on the same basic principles, and we can look at it and kind of understand how the circuit is put together. I don't have the schematic for this monitor, even though I'm sure I could probably look it up someplace, but I don't think I need it for this. And again, here's the flyback transformer, and you can see the horizontal circuit, horizontal output transistors right here. It's the linearity coil. You know, this is all very common horizontal stuff. We're not having a horizontal problem, we're having a vertical problem. And this chip here, this is the vertical output chip. Remember, this is just like in that TV. It's the single chip with a lot of pins, and this drives the vertical deflection. And there's another. This is the kind of a vertical control, and then there's the actual vertical output chip. And we're having a problem with the vertical deflection circuit. So it's going to be in this circuit somewhere. Now, if we look at the board, we can see that it says that chip is IC402. And then this is IC401. These are the vertical chips, and this being the output. So I know then that, at least the way this monitor and the way most monitors are built, you can look at the board and you can see that the other components that begin with 400, all the 4 series, are in the vertical circuit. So like here's the D403, C412, C410. There's all the vertical parts begin with 4. Similarly with horizontal, like here's the horizontal output transistor, and that's Q502. So that means the horizontal parts begin with 5. And then you can kind of find the rest of the horizontal parts. So in our case, we have, this is a problem with the vertical, so, and I know it's going to be a capacitor because that's generally what causes this sort of fold over. So, I mean, I could dig out the schematics and try to really work my way through it or spend a lot of time on it, or I could just replace these couple of capacitors in the vertical circuit, and that should fix it. Obviously, you could simply recap the entire thing, and I know a lot of people are into bulk recapping a board, but in many cases, it's just not that necessary to replace every single electrolytic capacitor, especially in a monitor like this that's not very old. You can also see how the heat from the vertical circuit has kind of browned the board here. Like it's darkened here. The vertical circuit in this monitor seems to run pretty hot, and the heat will also shorten the life of the capacitors. And again, this is fairly common to a lot of sets in vertical circuits where the capacitors that are right next to this heat sink where the vertical is kind of get baked by the heat, and they dry up and they fail more quickly. So I'm just going to replace these couple of electrolytic capacitors, and I'm pretty sure it's going to fix it. Okay, and here we have that little monitor. I replaced 5 capacitors, and I put it back together, and it's working now. No longer, it doesn't have that line at the top of it anymore. You can see the color bars are nice and clear. There's no more flickery line. Got a crosshatch pattern, and there isn't a line repeated down here. So yeah, it was a problem in the vertical circuit, and without the schematics, without really spending a whole lot of time, I was able to just look at the circuit board, look at the vertical circuit, and recognize which components were in the vertical circuit, and then just change the couple of electrolytic caps in that circuit. I mean, yes, with more in-depth troubleshooting, one could figure out exactly which of these 5 caps is actually bad. But considering this represents about $1 worth of parts, it's a quick and easy way to repair a monitor without having to, replace every single capacitor or rebuild the entire thing. One question I get an awful lot is, what special tools do I need to work on CRTs? Although sometimes I think it's more of, the mindset is more of, what special tools do I get to buy in order to work on CRTs? You really don't need any. There are, the tools you see here on this bench are what I use for 95% or more of repairs. All basic stuff you should probably already have for working on old computers. I do have a couple of pieces of specialized equipment that I do find I use occasionally, but it's kind of rare. An example would be the high voltage probe. This plugs into my multimeter and lets me measure the high voltage of a monitor. And so, like, if it's 25,000 volts, this thing steps it down to 25 volts, so the meter can display the 25 volts. Not necessary. It's very rare you actually need to measure the high voltage of a monitor. I think the big thing that I use that's the specialized tool is a CRT tester. This is handy for what I do because I work on so many monitors, but generally speaking, you don't normally need this because most of the time the CRT is not the problem. CRT tester comes in more handy when working on very, very old TVs because you can check the condition of the CRT before you go to all the effort of trying to get it to work again. Basically, if you need one, you'll know you need it. It's not just a whim. Other than that, though, there's really nothing special here. It's all very basic electronics and very basic single-sided circuit boards we're dealing with. CRTs are not as scary as you might think. Another piece of specialty equipment that I use is a degaussing coil. This one is an old piece of TV serviceman's equipment that came from a hamfest or something. It's just a coil of wire with a plug on it and a momentary switch. but I'll show you more about degaussing later, and I'll show you how to build your own degaussing coil without needing any special tools or equipment. You can build your own degaussing coil by using the one from an old TV. The bigger the set, the better. This is a 32-inch JVC. This one was found on the side of the road, laying face down. It's beat up. It doesn't work. The picture tube's got a big gouge in it. It's really not worth fixing or dealing it with. But we can use the parts to build our own degaussing coil. First thing we need to do is take it apart. Looks like, I think it's a number 2. Yep, number 2. So now we have the set apart. You can see that the degaussing coil there. It goes all the way around the outside edge of the picture tube, and it's zip tied together, and it goes down into the chassis where it would plug into the circuit board. There's a thermistor on the circuit board that controls the degaussing coil, but we don't need that for this. We just need the degaussing coil itself. So all we have to do is clip it out of its zip ties and remove it from the set. Okay, so here's the degaussing coil we scavenged from that junk TV, and the power cord, also from the TV. And really all we're going to do is combine these two items. I'm going to cut these zip ties off of this. Makes it just one big loop, and then I can coil this up smaller. It's all coiled up neat and smaller. It's got some zip ties on it holding it into a nice ring shape. I can trim those zip ties off, and I can splice on this line cord, and it'll be ready to use. One word of warning though, I'm doing this in a 120 volt country. I'm in the United States. This works here. I have talked to other people in 240 volt countries, and some of the degaussing coils in their TVs are actually 120 volt coils with a great big resistor in there to knock the voltage down. So if you're trying to do this in a 240 volt country, I would be very careful. Check the circuit of the TV you took apart. You might want to run this this coil in series with a light bulb, or in series scavenge that resistor as well out of the TV. But in America, we have 120 volt line cords, or 120 volt AC line, and the coils are designed for 120 volts. We don't need any extra circuitry. So here's the degaussing coil I made. I spliced the cord onto the cable coming out of the coil, and it's all zip tied up, ready to go. So I know I touched on degaussing earlier and how the Earth's magnetic field interacts with a television set. And here's a good demonstration of it. So right now the TV is working and the colors are correct. But if I turn this upside down, now it's different with respect to the Earth's magnetic field, and all the colors are screwed up. And if I turn it right side up again, it's fixed. So now, let's say I moved this set and the colors were screwed up when I turned it on, and I needed to degauss it. I'm actually in my kitchen right now, owing to the fact that it's one of the few places in the house that isn't already full of magnetic media and computers, because you want to be away from other things that could be damaged by magnetism, basically. Here's the coil. I've got a power strip to turn it on and off with. I can plug in the coil. What you want to do is start away from the TV, turn the coil on, bring it close to the set, and then bring it away. And see, now the colors are fixed, and it only takes a few seconds. Now this coil gets hot. You can only run it for a few seconds at a time, but it's all you need. And so now the colors are fixed, but if I were to turn this the other way, right side up, now the colors are all screwed up again, so I'd have to degauss it again. Again, you don't want to run it for too long. These coils do get hot. It's important to turn the coil on and off when it's away from the set. Well, if you turn it on while it's close to the TV, if you turn it off when it's close to the TV, it'll impart a magnetic field on the shadow mask, and you're trying to remove the magnetic field, not create a new one.